We're going to finish up 1.5. And we're going to kind of move on. We talked about the distributive property. So for the distributive property, if I'm looking at this just using my x's, so if I have 2 times x plus 5, and this is kind of what it's telling you to do. 2 times x is 2x plus 2 times 5. If I just go ahead and do all my multiplication following PEMDAS, that's going to be 2x plus 10. So because I can't add unlike items and an x is a variable and a 10 is just a regular number, also known as a constant, this is as far as I can reduce this. But what this distributive property allows you to do is just get prepared to solve problems. Now, if you remember probably from FOIL, FOIL is basically the distributive property just with a fancy name on it. If you remember, it's like x plus 3 and then x minus 2. This is just a more fancy way of doing it. But once again, you take the x from 1, same x here, you just distribute it, and then I'm putting x minus 2 on this side. Actually, this should be positive 3. So basically all I'm doing is kind of splitting these. One goes to this side, one goes to this side, and the x minus 2 goes here, and then the x minus 2 goes here again. So if I continue to work this out, x times x is going to be x squared. X times negative 2 is going to give me 2x. 3 times x is going to give me 3x. And this is going to give me negative 6. So once again, by using FOIL, you generally can combine the middle items. So I'm just going to rewrite the external ones. Once again, 2 and a 3, these two don't match. So I subtract. 3 minus 2 is 1. X, the 3 is bigger, it's a positive, so this would be using FOIL. That's as far as I can move that one. And that's called simplifying it. So the next thing that we're going to cover after distributive property, and some of these get a little easier and a little shorter. So the next one after distributive property is called the additive identity property. And that's just a fancy way of saying that there's a unique number that when added to a number results in itself. Well, what does that mean? Well, that's just a fancy way of saying anything added to 0 is itself. So if I'm just substituting in a 2, 2 plus 0 is equal to 2. Any number added to 0 is itself. I can rewrite this the other way. 0 plus a is also giving me a. Once again, reverse these. 0 plus 2 is giving me 2. Now, I know you're looking at that and saying, yeah, no kidding. Anything added to 0 just remains the same. It doesn't change at all. The reason that's important, if you think back to our complementary and angles, and this was the formula, x plus y is equal to 90. Just going to work out another one real quick. Let's say that x is equal to 50. So if x is equal to 50, I just substitute that in. 50 plus y is equal to 90. Well, when I actually solve this, I'm kind of using the additive property, but we really hadn't addressed it yet. So in order, I have to use the opposite. I have to get rid of 50, so I subtract 50. Whatever I do on one side of the equation, always do on the other side. This is going to give me 40 on this side. This is going to give me y. 50 minus 50 is actually 0. So this is the way the problem actually works. But because anything added to itself, it just puts me at y is equal to 40, and I just drop the 0 off. So that's why that one is important. The next one, which is number 5, and there are only 7 of these, and like I said, these are getting shorter, is the multiplicative identity. And the multiplicative identity is basically just saying that a number multiplied by itself or multiplied by 1 is itself. So for an example, a times 1 is just a. And we've kind of already covered that in the first section 1.1. But if we substitute in numbers, 3 times 1 is the same thing as 3. And I can reverse these, so 1 times a is the same thing as a, just like 1 times 3 is still 3. Right? Any number multiplied by 1 just leaves it at that same number. And once again, the reason that this is important, looking at these, if you remember, if I just multiply not multiply, but add them, or no, actually multiply them, a times 1 is just going to leave you at 1a. Now you can leave it at 1a or you can leave it at a. It really doesn't matter. When we start solving these, we're always trying to determine what x is or what the variable is. It could be a. But if I come up with this answer and say 2x is equal to 4, then I haven't solved it. I need to solve for x. And the way I solve that one is I divide them both by 2. And of course, x just winds up being equal to 2. Then number 6 is called the additive inverse. If we go back to our properties, all that is telling you is that any number added to its negative results in 0. And basically it's just telling you, more so than anything else, it's just its opposite. So if I use a number in, it's just telling me that 5 plus negative 5 is just going to be equal to 0. Once again, if I go back to my problem, x plus y is equal to 90. And we're going to use the exact same numbers that we just used, that x is equal to 50. Once again, that's going to be 50 plus y is equal to 90. What allows you to move the 50 to the other side is the additive inverse. And all that is telling you is that whatever I do on one side, I do on the other. So I can subtract 50 from 50 and give me 0. Whatever I do on one side of the equation, I always do on the other side. And once again, because the property number 5, it allows 0 just to fall off. And then y is still equal to 40. So it's just showing you how to solve problems. That's all they are. And you've been doing that before. This is just putting a name to it, and I kind of refer back to them. So the last one that we're going to cover, and to me is probably the most important because you're going to use this one way past this class, is the multiplicative inverse. And basically, this all boils down to what I kind of already covered in the last section, but is the reciprocal. You're going to need the reciprocal to solve any problem in algebra. So all that is telling you is if I have a and I multiply it by its inverse, which is 1 over a, it is going to be equal to 1. Same thing as if I use 5 and I multiply 5 times 1/5, that is going to give me a 1 as well. Now the reason that's important is because, let's just go to a simple one, 2x is equal to 4. Now we know we divide that by 5, but basically we are multiplying that by 1/2. And I'm just putting a 1 under 2 so you can see I'm just flipping it upside down. Whatever I do on one side of the equation, I'm doing it on the other. I'll turn that one into a 4 over 1 as well, just so it makes my multiplication across easy. As long as you use the reciprocal, you don't need to do any more math. You're left with a 1, and this just leaves you with a 1x. And that's what you're trying to solve for, is just your x. If I multiply the top, it's going to give me 4 over 2. And 4 divided by 2 is just going to give me 2. So I'm coming up with the right answer, right? You can either leave that as 1x equals 2 or x is equal to 2. It doesn't matter. Now, that's a little bit more work, because all you know that you can just divide 4 by 2 and kind of come up with your answer, which is fine if that works for you. But when we start getting into our fractions and we say that 3/5 x is equal to 4 over 7, you're not going to be able to just quickly divide that. So once again, if I had 3/5, I'm going to use the reciprocal, which is going to be 5 over 3. Whatever I do on one side of the equation, always do on the other side of the equation. So if I multiply one side by 5/3, I can multiply the other side by 5/3. I don't even need to do any more math on this side. I know that if I use the correct reciprocal, this automatically comes with x. So I'm already halfway through the problem. The next thing I have to do is just multiply. 5 times 4 is 20. 3 times 7 is 21. So that's going to be my final answer. So by using a reciprocal, it just allows you to do them real quickly. Now, always use them for your fractions. Like I said, you can divide for the other ones. So, if I have 5x divided by 10, basically I'm multiplying each side by 5, but I'm also dividing by 5. So you can use a shortcut, but if you be consistent with your reciprocals, you're going to be consistently getting the correct answers.